So here we go for the Edexcel paper. It's from the November 2023 entry and it's paper 2. So calcs at the ready. Question 1. Some algebra to start off with, just simple expanding. So if you prefer the loops, feel free. It's not a quadratic. 3 lots of 2y, 3 times -5, 7 lots of y, 7 lots of 2. Simplifying is 13y, take away 15, add 14, ends up with -1. Factorising. So, not got a number on the end, no need for 2 brackets, just the 1. Numbers first, they're in the 3 times table. 3 2s are 6, 3 5s are 15. They've both got an x in common. We need x times x to give us the first x squared and a plus in the middle to give us the 15x. Changing the subject, transposition, whatever you want to call it. Opposites. Take away 11 from both sides. And for the final stage, second mark, divide both sides by 3. On we go. So we've got a percentage profit question. So first job, she spends 300. 54, this is where we get the calc out for the first time. 54 lots of £7.50 mean Karen is making or taking £405. So the actual profit is 105. The original amount is 300, and to change it to percentage, times by 100. So on your calcs, we get 35%. Number 3, extremely bog standard for a calc question. Capital. Percentage is 3% with a bit on the end, and power of 2, 4,500 times 1.034 squared gives me £4,811. It's 202 on the end. It's money, so it does need changing to 2 decimal places. Solving, let's isolate the x's, let's add x to both sides. Let's add 14 to both sides. Looks much more friendly. Divide both sides by 6. B5, one of them standard, very wordy questions with ratio. Organise your info. Chris, Debbie, Errol, 3, 4, 2. D gets 120. It's a multiplier of 30. And why is that very important? It tells us the amount they're sharing out is £270. We're then told some money is given away, yada yada yada. We now have the ratio of 2, 5, 3. Them added together is 10 shares, so let's focus on Errol. Errol gets 3/10 of the cash, or in other words, 3/10 of £270, which is £81. How much money did Chris give to Errol? Errol's up by 21. Number 6, difficult to picture, so draw a picture. From A, so there's A, is 147, so anything over the 90 helps you picture the relationship of where A and B is. If that's 147, this one must be 33. Now that isn't the answer because the bearing is clockwise. So we need to do 360 minus 33. We get 327 degrees. Number 7, always be careful. Centimetres, litres per minute, minutes. So let's start in centimetres. Volume pi times the radius squared times by the height. Now that answer, I'll work in pi. That answer would be in centimetres cubed. But let's not forget that 1 centimetre cube is the same as 1 milliliter. So we can go straight to milliliters if we do 15 squared times by 43. I'm getting the answer 9675 pi. It's in milliliters. We want the answer to be litres per minute. Divided by 1,000 will change it to litres, and dividing it by 0.47 will change it to minutes. So 9675 pi divided by 1,000 divided by 0.47. I'm getting 64.6, etc. But it wants nearest minute. 65 it is. Number 8, we've got 2 significant figures, and that second important number is in the 10 pence column. Now, why am I explaining it like that? Because it's important. For bounds, you go up and down by half the rounding amount. If the rounding amount is 10 pence, go up and down by 5 pence. £1.95 and £1.85. Oops. Number 9, cubic expansion. Pick any pair to go for first. I'll just go with the first two. X times x. X times negative 2 is minus 2x plus 7x. So I simplify it as we go. And then we got minus 14 on the end. Obviously, loops is good enough. If you like it, use it. But when there's 6 loops, I prefer grid. So top line, let's times everything by x. Bottom line, we treble everything. Simplifying, first term is x cubed, final term is minus 42, and then we've got, whoops, I already meant squared there. We've got 8x squared, and there 15, take away 14, we've got 1x. On we go. Number 10, good old probability trees with part B needing a shortcut. So as soon as you see a 0.87, the 1.13 goes in there. If we pass, probability of another pass, 0.94, so 1 minus that, and 0.73, 0.27 goes there. Now the probability of passing at least 1 is this one, that, and that, which you could do, feel free. 3 jobs, I'll just do 1 minus these 2. So 0.13 times by 0.27 is 0.0351, and 1 minus is 0.9649. If you'd have gone for the long way, it wouldn't be that long, let's be honest. On we go. So don't worry too much about this proportionality thing. Think about your graphs. Look at graph A. It's just a straight line. Y equals mx plus c. That's your straight line graph. Y is proportional to x. Graph B, you might have seen it as part, top right quadrant, of a reciprocal graph. That's that one. Graph C, we'll leave it. Graph D, you will have seen that. That's the graph of x squared. So that's a nice easy one. Now if you haven't seen the graph of root x, well now you have, because that's what it looks like. On we go to number 12. They've given you plenty of room, almost a little teaser, that you could draw a diagram. I'm not going to bother. It's only worth 3 marks. I'm not going to take up too much time. Midpoints. Look at the x's. Add them together and halve them. That's how you find halfway. Add them together, 4 halved. Add them together, 34 halved. Let's do the same for n. Add these two together, 12 halved. And the easy spot halfway between them is 22. And don't forget, no matter where 2 coordinates are, you find the distance between them. It's always going to be the hypotenuse of a Pythagoras on a right-angled triangle. So the horizontal distance there is 4. The vertical distance is going to be 5. So we need to be square rooting 41, 6.403, etc., etc. 6.4 will do. On we go. So number 13, an extremely standard higher paper question, just a bit non-standard in the fact you have to go into 10,000 x's, but here's why. So always let the decimal be x. Now if we multiply it by x, it means we get them nicely lined up so that the recurring pattern begins immediately after the decimal point. It'd be nice if they did that again, so the only way we can do that is if we move them all up. The only way to do that times by 1,000. So we get 10,000x equals 723, and all this nonsense when we subtract disappears. So the stage the examiners want to see is 723 over the 9990, which if you divide top and bottom by 3, you get what you're asked to find. Number 14, double proportion. One thing at a time. So top one, y is proportional to x squared. Y is 3. 0.5 squared is 0.25. If you multiply both sides, or divide both sides by 0.25, you get your k. It's 12, which means you've got your direct proportion. What am I doing? 12. Let's move on to part 2. Inverse proportion means over. Replace the x with 2. Replace the w with 0.2. Find k. Multiply both sides by 0.2. You've got your new equation for the inverse part. K is 0.4. There we go. We can now start answering the question. You're told that w is 2. So we've got to go to this equation. If we replace w with 2, we get x to have the value of 0.2. That now needs to go into there. So y equals 12 lots of 0.2 squared, 12 lots of 0.04, 0.48. Not the nicest, but a gold mine of marks. Speaking of not the nicest, bit of a messy one here. So, for histograms, always think about area, length, width, height, all that malarkey. So widths of each bar, make a note. Frequency means area, and frequency density means height. So let's do this bar. 10 divided by 4, means 2.5, and that's this bar here. So if that's 2.5, it then tells us the scale of the y-axis. Let's now look at this first bar. It has a width of 2, a height of 1.5. Multiply them, we get the 3 that we can fill in. It wants the last 2 bars, that's these up here, need drawing. So we do area, which is 9 divided by 2. So we need a height of 4.5 and a width of 2. Apologies, you use a ruler. I'm doing on this electronic pen. Yeah, that's rubbish. Yours should definitely be better than that. 7 divided by 5 gives you 1.4. So let's find the 1.5. Along we go. And down to 26. Oh, that's perfect. Absolutely nothing wrong with that. That is absolutely perfect. Honest. Now on to part C. So, if there's 43 students, add 1 is 44, halve it, we're looking for the 22nd student. This first bar, width 2, height 2, there's 4. Next bar, this second bar, width 4, also height 2, there's 8. So up to here, there are 12 students. This next bar goes from 16 to 20. That's a width of 4, height of 4. There are 16 students in here. Somewhere in here is our median. Now, my method for interpolation is lower boundary, which in this case is 16. And we've got 12 students. The 22nd students is 10 students into the bar. The 16 here means I need to be 10/16 into the bar, and the height of the bar, the width of the bar, is 4. So 16 plus in your calc 2.5. 18.5 seconds is my estimate, and the mark scheme agrees. Number 16. So, it's obviously trigonometry, but got this extra bit of parallel lines. Now, you've got the 112 here. Now, if you take away 112 and 42 from 180, you get this angle to be 26. Now, if you notice this angle of 112 and this angle here, they are co-interior. So 180 minus the 112 means this angle should be 68. But if you do 68 minus the 26, it means we get 42 there. Now, if you want the area of BCD, that's this secondary triangle here, you've got an angle, you've got 15.3. If you had X, which is BD, you'd be home and dry. You would be able to work it out. So, how are we going to get it? Well, if you look at our triangle ABD, we've got a cosine rule question. Let's scribble out their labels. Sorry, sine rule question. So we can say that X divided by the sine of 112 is equal to 7.9 divided by the sine of 42. So on your calcs, 7.9 divided by sine 42, then multiply that by the sine of 112. I'm getting X to be 10.9466. And it goes on, but I'll just leave the number in my display. So now we know how big X is. We can say that the area formula is in the formula sheet. It's a half times the sine of 42 multiplied by the two sides which I split by the angle, so the 15.3 and the 10.9-ish. So 10.9 times 15.3 divided by 2 times sine 42. We've got 56 as the area. It wants one decimal place, 56.0. And as I'm just doing that, I've realised that was 42. So was that. Didn't need to do the co-interior, but hey, it's all good revision, right? Number 17. So, show that it's got a solution. Take your x of 1, sub it in. So 1 cubed plus 2 ones, take away 6 is minus 3. Sub in your 2. 2 cubed is 8. Plus 2 2's, take away 6 is 6. So we've got a change of sign, and it's a continuous. Get into good habits for your A-level. They want that. So you need to say change of sign, and also it's a continuous graph. So a solution must lie between 1 and 2. Next one, show that it can be rearranged. Well, as you can see, there's a clue there that you've got x squared plus 2 on the bottom and a 6 on top. So let's start by adding 6 to both sides. And then there's an x in both terms. Let's take an x out. And the pieces of the puzzle start to fit. So leave x where it is. and divide both sides by x squared plus 2. On we go, iteration. So don't worry about the terminology. You're told the first number is 1.45. So all you do to get the second number is do 6 divided by 1.45 squared plus 2. So on your calcs, 6 divided by, I'd recommend opening brackets, 1.45 squared plus 2, close your brackets, equals. It wants 4 decimal places to finish with, so make sure you give this answer to more, and it goes on. So we can take that and we can do 6 divided by, open brackets, 1.46252285 squared plus 2, close brackets, equals, and I'm getting 1.44963, and so on. It asks for 4 dPs, so give 4 dPs, 1.4496. We'll leave it at that. So a bit of a tricky vectors for number 18. Let's start by realising that it's all about midpoints. So A to H is A, so that is as well. A to E is B, so we have another B up here. And D to G is C, and so's that. So we need to look at the parallelogram EFGH. Now I'll just say, going from E to H and H to G, they're easy. It's this BC line that's the tricky bit. So let's start with that. Let's do the line B to C. You can't go there directly, so it's all the way round the long way. It's against 2 B's. It's with 2 A's. And it's with 2 C's. And we can also make the statement, therefore, that half of that, so if we need it, B to F is minus B plus A plus C. So let's do the easy bits. Let's go for E to H. If we look at the line, how do we get from E to H minus B plus A? Let's go from H to G. That's A plus C. Now let's go for the harder ones. Let's go for G to F. Now to go from G to F, you need to go G to C, which is C. That's that part of the journey. And you need to go C to F, which is in the opposite direction to this. So we're going to add on a B, take away an A, take away a C. Or in other words, the C's cancel. B. They obviously look similar. If we take a minus out, we can say that they are a multiple of each other. They're basically the same size. The only reason for the minus is the direction I've took it in. Should have really gone F to G, but we live and learn. H to G is one that I've done. So now let's do E to F, the line which is supposedly parallel. So E to F is going to be E to D, which is B, and B to F. So we take away B, add A, add C. The B's cancel. The presto. And now you need your concluding statement. I'll leave that to you, but all you need to get across is the fundamentals of what makes a parallelogram, and that's equal and opposite sides. Those two, they're equal and opposite. Those two are equal and opposite. They're a multiple of each other, they're parallel, and so on and so forth. So functions, we like functions. So g of f, so you work your way inside out. -3 needs to go into there first. So 2 lots of -3, -6. Add 3, use your calc if you need to, is -3 squared. So we get 9. 9 now goes into there. Double it, take away 1. So 18 minus 1 gives us 17. Inverse functions, most teachers will go for this way of setting it out, but not all. It's not essential. Adding 1 to both sides, dividing both sides by 2 means you've rearranged it. That's the inverse function. Just switch around. Some people say flip your y's and x's. And there you go. So number 20, it's got some slightly off-putting looking algebra, but don't let it. So if big maths tells us anything, it's work on the brackets first. So we've got the x plus 4 inside the brackets, but really the work is here. Dividing by means multiply by the reciprocal. So the 2x plus 3 bounces up to the top. This 2x squared, etc., now come to the bottom, but notice they're all even. We can take a 2 out. So really we're factorising x squared minus 3x minus 28, and two numbers which multiply to make negative 28 and add together to make -3 is x minus 7 and x plus 4. As you can see, we've got an x plus 4 on top and x plus 4 on the bottom. So that stuff really disappears. So what we've got over here, we've got 14 over 3 lots of x minus 7 added. Here we've got 2x plus 3 lots of 2x minus 7. You can add them when the denominators are the same. So let's turn the 3 and the 2 into 6. So to do that, we'd need to double the top and treble the numerator over here. 6x plus 9. So the top result means we have 6x and 37. And because of the way we're asked to write it, we'll expand the brackets on the bottom to give us 6x minus 42. Not so bad in the end, but all the time with questions like that, everything cancels, loads of stuff disappears, and you end up with an answer going, and you end up thinking, oh, is that it? And finally, number 21. An over-the-top, confusing looking Venn diagram, Vicky and her medals. So, English medals is the A circle. Gold medals is there. So, I'm going to pick at random now. Here's what, given that the medal is gold, that means we only care, we are assuming we have picked out of the gold medals. The total of the gold medals is 6x minus 3. We've added them together. Find the probability it is English. How many of these are English medals? It's the x in the middle. And we're told that this probability is 2/11. We've got an equation. Let's get it solved. So let's cross multiply. 11x. Let's times both sides by 6x minus 3. In other words, double this. 12x minus 6. Adding 6 to both sides. Subtracting 11x. We get the value that x is 6. But it doesn't ask for that. It asks for how many medals are in the collection. So x is 6. 7 6s are 42. So take away 11. 31 in that circle. We've got 5 6s are 30, so 27 in that circle. And we can now add them up. We've got 31 and 6, 27, 34. Yep, I forgot my calc. 11, 12, 18, 3, 4, 5, 6, 7, 8, 98 medals in Vicky's collection. Good for her. So I hope that helps, and I'll see you on paper 3.